Okay, so what I want to look at is the coordination of our aminodiacetic acid ligand to our metal complex or our metal centra. And essentially, you've done in second year, you've looked at Baylor's method. So you already should recognize that this ligand is of the form A, B, A. And then if you write out Baylor's method with only the options, well, there's an A and a B, then you should be able to find out how many permutations there are. But we have the added limitation or geometric limitation of that these ligands or these atoms need to be arranged geometrically according to the ligand's architecture. So meaning that this A and that A technically are two different A's, but they need to be coordinated in the order of A, B, and A, right? Always in that order to bond together with this ligand, because this is a tridentate ligand, as we spoke about in the pre-practical lecture video, right? But I've realized as I've presented this course for a few years now, this is generally something that is struggled with. So what I do is, or what I'm going to try and do in this video, is give you a nice way to visualize these things. So on a piece of paper, you take just general octahedra. So you have two bonds coming out of the plane, two bonds going into the plane, and two bonds in the plane, right? So that's what the dash bonds mean, going into the plane, thick bonds mean coming out, and straight bonds mean just in the plane. And then you also need your model building kit. So something like that. Okay. And in this case, my white atoms represent oxygen atoms, and then my nitrogen atoms are represented by the green atoms. Okay. Or green balls, or whatever you want to call them. And we want to figure out how many ways can we coordinate with, or coordinate this ligand with this metal uniquely, right? And of course, which will still allow the ligand to obtain or to have its architecture, and the ligand not to break in any funny ways or bend in any funny ways or whatever. Okay, so we also learned about different terms, right? Isomeric terms. So we learned about cis and then trans, and then we also learned about meridional, and we learned about facial. Right. So how are these terms going to help us from the pre-practical lecture? Well, first we start off by saying, well, we want to place our different atoms of the ligand, either cis or trans, and then we want to make the ligand sit meridionally or facially on the complex. Right. So now that I've lost all of you, let me explain, we're using the model or the model kit, what that means. So let's say I want to start with my atoms cis to one another. So in other words, my two nitrogen atoms are always placed in the molecule or in the complex, are placed cis to one another, and then my oxygens are always cis towards one another. So you see all the bond angles between the oxygens are 90 degrees, and all the bond angles between the nitrogens are also 90 degrees. Right. So how does this look in 3D? So let's put it something like that, for example. Let's say make it this one. So this one is called cis now. And we have a nitrogen on top here, which is this nitrogen. We have a nitrogen coming out at us, and then the rest are just oxygens, right? Oops. Right, so we have a cis one over there, but anyway, with the oxygens. And let's also make the bottom one cis as well. You'll see in a moment why we have 4 different options, because remember, we need to do a meridional and a facial one, because we have a cis option with the atoms, and then the ligand needs to be either meridional or facial, which I'll explain in a moment. So we just need to quickly draw the exact same structure at the bottom as well. Okay, so what does it mean when I say the ligand needs to be meridional or facial? Well, the ligand needs to be connected in a meridional or facial fashion. So remember, meridional means that the ligand is spread over 180 degrees. So meaning that you see a bow like that, 180 degrees. And facial means that you have something that sits at 90 degrees to one another. So it sits on the face of your octahedra, right? So remember, in the pre-practical lecture video, we saw something that went on the 3 bonds of the octahedron, something like that. And then something that sits on the face of the octahedron is called facial. Okay, but we have our requirement that these need to be in the order of oxygen, nitrogen, oxygen. So how do we identify them in that order on this sketch here? So here we have our octahedron. So we need to keep it cis. So let's call this one facial. So cis facial, cis meridional. All right. So if I want to make a facial structure from this, I need to go oxygen to a nitrogen to an oxygen, right? And are these all 90 degrees apart? Yes. Is that on the face of an octahedron? Yes. See the face there? You see it sits on that face. If we keep it upright, it's that face of the octahedron. So which ones do we need to connect? We need to connect these 3 are connected. And that then just leaves those 3 to be connected. And we can easily see there at the back, those 3 also form a facial structure. So basically, if you take your hand like that, you can see it sits on the face. Just like that. Bah. It's a facial isomer. Right. And the nitrogens are cis to one another. So we have a cis facial structure. If we have the same structure, but now we want to connect them meridionally. How can we do that? Well, meridional means we need to connect something in a plane, basically. So, well, we have an option here. So if we take this oxygen to this nitrogen to that oxygen, that's an option. So there we have 180 degrees. But then we're left with something interesting. So we need to take that oxygen to that nitrogen, to that oxygen. Because remember, we need to keep oxygen, nitrogen, oxygen, because that is how the ligand's architecture is. You can't change that. So that order is important. You can't all of a sudden bond oxygen to nitrogen. Okay. And remember, these bonds that I'm drawing is actually just this architecture here. I'm just being lazy. This needs to be technically whatever. And then the thing comes here or whatnot. So you need to draw that out. I'm just doing a very shorthand. Okay. So that's how you've dissociated those 2 isomers. So what's left? We need to do the trans versions. So a transfacial and then a trans meridional. Okay. And again, so now what do we do now? So we had our ligands cis to one another, or our atoms cis. So let's quickly just swap those 2. So now we see our nitrogens are trans to one another. So let's fill in our octahedron. And then you go about, you look for a facial isomer. Can you see the facial isomer? If I hold it like this, where do you put your 3 fingers? That they form a 90-degree angle with one another, or basically form the face of an octahedron. I'm hoping you said oxygen, nitrogen, oxygen, and there at the back, oxygen, nitrogen, oxygen. So the 3 at the back are connected to one another, and the 3 in the front here are connected to one another. Right. And again, the bottom one here, nitrogens are trans, all the oxygens are trans to one another. You'll see, so those oxygens are trans, even though they are cis, but that's just the formality. So just keep track of the nitrogens, really. The nitrogens are cis in these ones. The nitrogens are trans in these ones. But now we want meridional. So what does meridional require from us? Meridional requires 180-degree bond. So in other words, so we need to keep oxygen, nitrogen, oxygen, oxygen, nitrogen, oxygen. So oxygen to nitrogen, nitrogen to oxygen, oxygen to nitrogen, nitrogen to oxygen. And those are all 180 degrees. Right, so from these, then you need to basically argue which ones are most likely to form, which ones are the ones you made, which one is the dark orange product, which one is the purple product, and that you should be able to use your basic knowledge of steric hindrance and whatnot. And of course, one of these completely won't form, one of these is very unlikely to form, and then two of these are the actual products. So I hope you followed this and you used your model building kit. I mean, you can even include in your report your pictures of your model building kit, or you can use something like Mercury software or whatever, or Avogadro to plot your 3D conformers if you would like to do that. And remember, you're not allowed to do the shorthand or whatever. You need to use your chemistry software and draw out the full ligand here at the back. So I want to see the full architecture in each of these structures when you do them. But this is basically the structures already. You just need to go and fill in the gaps. Right. I think that is it. It should answer most of your questions. If you had any still after the lab, it's also that little part that I ask in the prac manual that you need to fill in, those 4 empty blocks. It's basically just this, that you need to fill those structures in. So if you didn't do that in the lab, then you have them now. All right, that's it. Thank you for watching.